This is our fluorescence spectrometer. We have an air cooler. So this is our air cooler. There is a fan here and we have a light source. You can see the excitation monochromator here. This is excitation monochromator. So you can see the wavelength. It is adjusted to 330 nanometers. And we have slits. These are two slits. So this is the slit for the light, this is the slit for the excitation monochromator, and this is the sample compartment. We have two different filter parts. So we can put the filter here. For instance, we can put filter here, and we can put a filter here. We remove the filter, by the way, so we close this part. So there is no filter right now. And we have a sample compartment. So this is the switch to protect the detector. So when the switch is on, then detector doesn't take light, it protects the detector. When you close it, then light can go to the detector. And this is our sample compartment. So we can adjust the angle of the sample, and we put the sample inside this sample holder. So as you see, there is a small cavity. The depth is approximately 1 millimeter, but I will talk about it in the next part of the video. So this is our sample compartment. So I will use it, I can take it. And this is the emission monochromator, and wavelength right now 650 nanometers approximately, and this is the PMT detector. And by the way, there is a shutter, and we can turn it on or off. So this is the device. And by the way, we have a water cooler unit. So this is a cooler for the PMT detector to improve the signal to noise ratio. And this is the control unit. So actually two computers controls the spectrometer. But today I will mention about the sample preparation for our spectrofluorescence spectroscopy experiment. The issue is that I have a very small sample and I have to recover my sample. Therefore, I will put copper tapes inside the cavity. Then I will put indium foil. After putting the indium foil, I will put my sample and take the spectra of the sample. So here I have a sample. So this is my sample, and as you see, it is pretty small amount. So I have to be very careful to prepare it. So I have to recycle my sample after the fluorescence spectroscopy. Therefore, what I will do is that I will take this copper tape. So I have a copper tape here. I will put the 4 layer of copper tape inside this cavity. Then I will use my indium foil to increase the sticking effect of the powder sample. Then I will put the powder on the surface. So this is my plan. firstly, I will cut small pieces from my copper tape. Okay, I will remove the papers. So it is copper, as you see. I will paste it on the sample compartment. Okay. I am pasting on the copper. Then I will take the paper. And you can see the copper. So this is just the first layer, and I will do 3 of them on this copper surface. So the important point is that on this cavity, on the surface of this cavity, there should be only my sample. I don't want any light reflection from copper, indium foil or other things. I made my second layer. I will make my third layer. So this is a little bit long. This is the third layer. And I will put my last layer. So 4 layer is pretty good and enough for me. This is the fourth layer. And I will put my indium. So maybe I can use any used indium foil. That's damaged. So this is for instance, an indium foil. So it is clean actually, but the size is not enough. So maybe I should cut a small piece. I will put a small piece. Okay. And this is our indium. I have to clean my indium. I will just use acetone to do that. And I will not sonicate. If I sonicate the indium separates and it actually becomes a powder. So I will just use acetone. Okay. So I used acetone. It will dry in a few seconds. And I will put this indium on this surface. And indium is very soft metal. When I press my sample on the indium, it will stick. And I am pressing the indium right now to stick to the copper tape. Okay, and for the corners, but it is not very easy. Okay. So indium shouldn't go to indium shouldn't be out of the cavity. It is important, and I think I could put the indium foil. So this is my modified sample compartment, and I will put my powder. So there is small indium foil here. I want to take it. I can recycle it. And this is my sample. Powder nanoparticle sample. So it is very precious for me. I have to spend 2 weeks to synthesize it. I will put it on the surface. And I will press it by using this copper piece. And this is my sample. So I can put my sample inside the spectrometer. I take the spectra of my sample and I want to recover this powder since it is precious for me. So I can take it from the surface, since there is just a friction between indium foil and the powder sample, and I took it. So I can't take all of them, maybe, but it is good enough. So still I have little bit powder, but it is fine. And if you want to look at the indium foil, this here, so I took a little bit small piece. I will try to remove it. So unfortunately I cannot recover my indium foil. It damaged a lot. I pressed pretty harsh at the beginning. So unfortunately I broke the indium foil, but I can make a new sample on this copper surface. Luckily I have enough indium foil, or this is the case. And I will take my sample. What is this? I will take my samples to the vial. And I hope this video was helpful for you. Thank you.